So we're continuing here in section 8.2, graphing more complicated rational functions. So first thing we want to do is we need to factor the numerator. In this case, it will factor to x plus 2, x minus 1 over x plus 3. So first thing we look for, are there any holes? Does there anything cancel in the numerator and the denominator? Nothing does, so we're not going to have any holes, no points of discontinuity. So next we look for vertical asymptotes. That's what's in the denominator that didn't cancel. So in this case, we'll have a vertical asymptote at x equals -3. Looking for horizontal asymptotes is when we look at the powers of the numerator and denominator. In this case, the top is bigger than the bottom. So what we'll need to do is we will actually need to divide. We're going to have a slant asymptote here. So no horizontal asymptote. We'll have a slant asymptote. What we need to do is divide. So this one is already set up. We can do synthetic division. So if we're dividing by x plus 3, that means we'll have a -3 in our corner. Take the coefficients 1, 1, -2, and we can do our division. So we'll bring down the 1 right away and then multiply. -3 times 1 is -3. Add down 1 minus 3 is -2. Then we multiply. -3 times -2 is a +6. And add down -2 plus 6 is 4. Now, in this case, we're not actually going to worry about the remainder. We're going to take these coefficients, and that's going to give us what our equation is for our slant asymptote. So it's going to be the line y equals x minus 2. So our domain, x cannot be -3. And because we have a slant asymptote here instead, we're not going to worry about the range. The last thing we want to think about is the x-intercepts. That is what's in the numerator that did not cancel. So it'll be at -2 and +1. We'll have two x-intercepts here. So we're going to have a vertical asymptote at x equals -3. And then a slant asymptote at the line y equals x minus 2. So we're going to have a y-intercept at -2 and then a line with a slope of 1. Let me just get a sketch here of what that's going to look like. It's going to be something like that. We're going to cross at -2 and at +1. So hopefully we can kind of see which quadrants we're going to be in. But we can go ahead and graph this in our calculator. So we'll have x squared plus x plus x minus 2 divided by x plus 3. And we graph that. And so we can see we're going to be down there at the bottom and then in that top portion. So it'll be something like this. And then something like this down that way. Okay. So last problem we're going to look at here. First thing we need to do is factor the numerator and the denominator. That'll become x minus 2, x plus 1, and x plus 3, x minus 2. So first thing we look for is anything canceling. This time we do finally have something canceling, our x minus 2s. So that means we will have a point of discontinuity, a hole at x equals 2. Vertical asymptotes, what's left in the denominator that did not cancel? So in this case, x equals -3. Horizontal asymptotes, we look at the powers. They're both degree 2, so we'll take the leading coefficients, put them in a fraction. They are each 1, so 1 divided by 1 means we'll have a horizontal asymptote at 1. Because we have a horizontal, we will not have a slant. Domain, x cannot be -3 and x cannot be 2. Those are both domain issues in our original function here. And our range, y cannot be 1. Last thing we check is for the x-intercepts. That's what's in the numerator that did not cancel. So in this case, we'll have an x-intercept at -1. So when we graph these, we'll have a vertical asymptote at -3. It's going to be over here. We've got a hole at 2. What I'm going to do first is I'm going to graph the line and then draw in the hole later, just because I'm not sure where position-wise that hole is going to be. So I'll have a horizontal asymptote at y equals 1, so that's here. and an x-intercept at -1. So I can already tell which quadrants I'm going to be in, but I do want to double check here with my graph. So we have x squared minus x minus 2 divided by x squared plus x minus 6. We graph, and yep, there it is, right where I expected. So we're going to be in these two diagonal quadrants, here and here. So now that I know what my general shape is, I'm going to look over here at x equals 2. Normally I would erase, I don't think I can with my pen that I have here, but at x equals 2, I'm going to draw in a little circle that's showing there that I have a hole there, since we do have that hole, that point of discontinuity at that point.